Sequences and series. So we all know what is a sequence. A sequence is basically a succession of real numbers. Sequence is nothing but a succession of real numbers which are generated by a particular mathematical formula. So sequence is basically a succession of real numbers which has different terms in it. So the terms of a sequence are written in order as the first term, the second term, the third term, etc. So and the terms are denoted by T. For example, if we consider a sequence that T1 is the first term, T2 is the second term, T3 is the third term, and Tn is the nth term. So this is basically a sequence of n terms. Now, if we go on to calculating the sum of the terms, that means the sum of first n terms. The sum of first n terms is denoted by Sn. The sum of first n terms is denoted by Sn. So if we want to calculate S2, so what does S2 mean? T1 plus T2. S2 means that sum of the first two terms, that means T1 and T2. S3 means the sum of three terms, that means T1 plus T2 plus T3. So sum is represented by this. So if you want to so by sum we can know the T, that is Sn minus 1 would give us the term. So this we got to remember. Now we'll see what is an arithmetic progression. Arithmetic progression is denoted by AP. A sequence Tn is in AP if Tn plus 1 minus Tn is equal to D. So this is the Tn plus 1 term minus its previous term, Tn is equal to D, where D is basically a constant which is equal for all the difference between the two successive terms. So D is known as the common difference and it's always a constant. So what are the following? These are the following points that we need to remember in an arithmetic progression. A, the first term is always represented by A. So means if we have a sequence, so the first term is always denoted by A, and D is nothing but the common difference between them. So if we go on, so if we want to write an arithmetic progression, then how would we write? Just by representing these both. We know that the first term is A, so A. The second term would definitely be A plus D. The third term would be A plus 2D, A plus 3D, and so on. So this is basically a arithmetic progression that we got from the first term and the common difference. The second thing that we need to remember is the formula for the general nth term. The formula for the general nth term is Tn is equal to A plus n minus 1 into D. So this is the general formula for the nth term, where Tn is the nth term, A is the first term, n is the number of terms, and D is the common difference, as we all know. The third point is if the nth term is L. If the nth term is L, the sum of first n numbers would be Sn is equal to n by 2 upon A plus L. So this is Sn is a sum of all the terms, sum of all n terms is equal to n. N is the number of terms by 2 upon A. What is A? A is the first term and L is the last term, that is the nth term. So this formula would also help us remembering that is the sum of first n natural numbers is given by the formula n plus n plus 1 by 2. So if they ask find the sum of 5 natural numbers, then it would be 5 plus 1 by 2. Now the groups of terms in AP. So if we have been given 3 terms in AP, then how would we denote it? 3 terms would be denoted as A minus D, A plus D. So this would basically help us solve the sum where we have been given an AP of only 3 terms. So this would be A, the previous term would be A minus D, and this term would be A plus D. Similarly, 4 terms are given, then it would be A minus 3D, A minus D, A plus D, and A plus 3D. And similarly for 5 terms, it would be A minus 2D, A minus D, A plus D, and A plus 2D. And we also need to remember that if in the question, if it's given A, B and C are in an arithmetic progression, then we always note that A plus C is equal to 2 into B. So if these three are in arithmetic progression, A plus C is equal to 2B, that might help us solve many problems. So now the second important concept that we'll see today is the harmonic progression. This is the harmonic progression, that is HP. So if 1 by T1, 1 by T2, 1 by T3 are in an arithmetic progression, then T1, T2 and T3 are said to be in harmonic progression. So basically, if any terms are given to us, then the reciprocal, if the terms are in AP, then the reciprocal of the terms are in the HP. So we don't use any general formula. So if we have been given that 1 by 3, 1 by 2 and 1 by 5 are in AP, just example, then 3, 2, 5 are in HP, then 3 to 5 are in AP. So if we have been given any sum in which harmonic progression is given, we always convert them into arithmetic progression and then apply the formula. There are no general formulas for Tn and Sn as we had seen in AP. So there are no such general formulas like Tn and Sn is in SP. So whatever the questions that we have been given to us, so questions on HP are solved by treating the reciprocals of the given terms as AP.
If f is a differentiable function of x, then limit h tends to 0, f of x plus h the whole square minus f of x the whole square upon 2h is what? And these are the options. So this is in the form of a square minus b square. So we split the term, we get limit h tends to 0. This is a plus b, a minus b. So this is f of x plus h plus f of x upon h into f of x minus f of x plus h minus f of x upon this can be rearranged as limit h tends to 0, 1 by 2 f of x plus h plus f of x into limit h tends to 0, f of x plus h minus f of x upon h. Now this term is the definition for f dash of x, that is differentiation of f of x. So this is limit h tends to 0, 1 by 2 f of x plus h into plus f of x into f dash of x. Now we put the limits, we get h is 0, so this is f of x plus f of x into f dash of x. This is 2f of x upon 2 into f dash of x. 2 gets cancelled, we are left with f of x into f dash of x, which is option B. If f of 1 is 1, f dash of 1 is 2, then limit x tends to 1, root of f of x minus 1 upon x minus 1 is what? The options are 1, 2, 4 and 1 by 1 by 2. First we multiply and divide by its conjugate. So this is limit x tends to 1 root of f of x minus 1 upon x minus 1 into root of f of x plus 1 upon root of f of x plus 1. So now this is in the form of a plus b, a minus b. So this is a square minus b square, that is limit x tends to 1 f of x minus 1 upon x minus 1 into root of f of x plus 1. Now we split the term. So this is limit x tends to 1 f of x minus 1 upon x minus 1 into limit x tends to 1 upon root of f of x plus 1. Now this term is f dash of 1. This can be written as f dash of 1 since f of 1 is 1. So this is f dash of 1 into, we put the limits here. So this is 1 upon root of f of 1 plus 1. So that is f dash of 1 into 1 upon f of 1 is 1. So root of 1 plus 1. Now f dash of 1 is 2. So this is 2 into 1 by 1 plus 1. That is 2 by 2, which is equal to 1, which is option A. Differentiation of 7x square minus 2x plus 4 divided by x raised to 5 is, these are the options. So first we split the term. So d by dx of 7x raised x square upon x raised to 5 minus 2x upon x raised to 5 plus 4 upon x raised to 5. We bring this term to the numerator. So we get d by dx. So this is 7 upon x cube minus 2 upon x raised to 4 plus 4 into x raised to minus 5. That is d by dx of 7x raised to minus 5 minus 3 minus 2x raised to minus 4 plus 4x raised to minus 5. Now we differentiate it. We get minus 3 into 7 into, this is n into x raised to n minus 1, the differentiation of x raised to n. That is minus 3 into 7 into x raised to minus 3 minus 1. And similarly 2 into minus 4 into x raised to minus 5 plus 4 into minus 5 into x raised to minus 6. So that is equal to minus 21 x raised to minus 4 plus 8 x raised to minus 5 minus 20 x raised to minus 6, which is, so now we check the options. Now we take minus 1 common throughout. So this is minus 21 x raised to minus 4 minus x raised to minus 8 x raised to minus 5 plus 20 x raised to minus 6. So this is option B. Differentiation of log of x raised to n by e raised to x is, these are the options. So by rule of logarithms, we can write this as log of x raised to n minus log of e raised to x. Again we can rewrite this as n into log x minus x into log e. Now log e is 1 since the base is e. So this is d by dx of n log x minus x. So now we differentiated. Differentiation of log x is 1 by x. So this is n by x and differentiation of x is 1. So n by x minus 1, which is option C. If u is root of 1 plus 2 sec x tan x plus 2 tan square x, find u dash, that is differentiation of u. We rewrite the expression of u, 1 plus 2 sec x tan x plus 2 tan square x. Now we split this term. We can rewrite this as root of 1 plus tan square x plus 2 sec x tan x plus tan square x. Now 1 plus tan square x is sec square x. So this is root of sec square x plus 2 sec x tan x plus tan square x. So this is the formula for a plus b the whole square, that is sec x plus tan x the whole square. So this is u equals root of sec x plus tan x the whole square. So u is equal to sec x plus tan x. So this is simplified form of u. So let this be equation 1. Now we differentiate it. We get u dash is differentiation of sec x is sec x tan x, and differentiation of tan x is sec square x. Now we take sec x common. So this is sec x into tan x plus sec x. But this term is u from equation 1. So this is u into sec x. U dash is u into sec x, which is option A. If y is x square minus 1 upon x square plus x plus 1, then the value of x square, then we need to simplify the term x square plus x plus 1 the whole square into y1. So these are the options. So first we differentiate y. So y1, that is first derivative of y, is this is in the form of u by v. So it is v into derivative of u, that is x square plus x plus 1 into derivative of u, that is 2x, minus u into derivative of v, that is derivative of this term is 2x plus 1 upon v square, that is x square plus x plus 1 the whole square. So we have to find the value of this term. So we multiply it on both sides. So this is x square plus x plus 1 the whole square into y1 is equal to x square plus x plus 1 the whole square into x square plus x plus 1 into 2x minus x square minus 1 into 2x plus 1 upon x square plus x plus 1 the whole square. So this term gets cancelled. We are left with x square plus x plus 1 into 2x minus x square minus 1 into 2x plus 1. We expand the brackets, we get x square x square plus x plus 1 into 2x minus, we split this term, so this is 2x into x square minus 1 minus x square minus 1. We split this term. So now we take 2x common in these terms. So this is 2x into x square plus x plus 1 minus x square plus 1 minus x square plus 1. So x square gets cancelled. So this is 2x into x plus 2 minus x square plus 1. So this is 2x square plus 4x minus x square plus 1. So 2x square minus x square is x square. So x square plus 4x plus 1, which is option D. If y is x square plus x plus 1 upon x square minus x plus 1, then the value of x square minus x plus 1 the whole square into y1 is. So these are the options. Again we differentiate y with respect to x. So y1 is, this is in the form of u by v. So this is v into derivative of u, that is x square minus x plus 1 into derivative of u, so that is 2x plus 1 minus u into derivative of v, that is 2x minus 1 upon v square, that is x square minus x plus 1 the whole square. Now we multiply x square minus x plus 1 the whole square on both sides. So we get x square minus x plus 1 the whole square, y1 is equal to x square minus x plus 1 the whole square upon x square minus x plus 1 the whole square into x square minus x plus 1 into 2x plus 1 minus x square plus x plus 1 into 2x minus 1. So this term gets cancelled. So LHS is x square minus x plus 1 into 2x. We split this term, we expand the brackets, so we get x square minus x plus 1 into 2x plus x square minus x plus 1 minus x square plus x plus 1 into 2x plus x square plus x plus 1 into minus 1 into 1. So finally simplifying these terms, we get 2x into x square minus x plus 1 minus x square minus x minus 1 plus 2x square plus 2, that is 2x into minus 2x plus 2x square plus 2, that is equal to minus 4x square plus 2x square plus 2, which is 2 minus 2x square, which is equal to 2 into 1 minus x square, which is option A. Differentiation of sin x upon 1 plus cos x is, these are the options. So differentiated d by dx of sin x upon 1 plus cos x. This is in the form of u by v. So it is u v into derivative of u, that is cos x, minus u into derivative of v. So derivative of 1 plus cos x is minus sin x upon 1 plus cos x the whole square, that is v square. So this is 1 plus cos x plus cos square x plus sin square x upon 1 plus cos x the whole square. Now cos square x plus sin square x is 1. So this gives us cos x plus 1 upon 1 plus cos x the whole square, that is equal to, now cos x plus 1 is common, so we this gets cancelled, we are left with 1 upon 1 plus cos x, which is option B. If y is a minus b cos x upon a plus b cos x, then a plus b cos x the whole square into y1 is, these are the options. So firstly differentiate y with respect to x. So y1, that is first derivative of y is, this is in the form of u by v. So it is v into derivative of u, that is a plus b cos x, into derivative of minus b cos x is minus of minus b sin x. So this is v into derivative of u minus u into derivative of v, that is a minus b cos x, into derivative of this term is minus b sin x upon v square, that is a plus b cos x the whole square. We take this term to LHS, so we get the required LHS. So this is a plus b cos x the whole square into y1 is equal to a plus b cos x into b sin x minus a minus b cos x, we take minus 1 outside, so this is plus a minus b cos x into b sin x. We expand the brackets, expanding the brackets we get ab sin x plus b square sin x cos x plus ab cos x plus b square sin x cos x. There's a correction here, this is sin x and this is minus 1, since this term contains minus 1. So this term gets cancelled, where we are left with ab sin x plus ab sin x, which is equal to 2ab sin x, which is option B. If y is a plus b sin x upon a minus b sin x, then a minus b sin x the whole square into y1 is, so first we differentiate y, so y1 is, this is in the form of u by v, so differentiation of this term is a minus b sin x into derivative of numerator, that is b cos x minus a plus b sin x into derivative of this term, that is minus b cos x upon a minus b sin x the whole square. We shift this term to LHS, so we get a minus b sin x the whole square y1 is a minus b sin x b cos x minus a plus b sin x. So this is plus 1, we take minus 1 common, and this is b cos x. Expanding the brackets, we get ab cos x minus b square sin x cos x plus ab cos x plus b square sin x cos x. This term gets cancelled, we are left with 2ab cos x, which is option D. If y is a cos x plus b sin x upon a sin x plus b cos x, then a sin x plus b cos x the whole square into y1 is, these are the options. Again we derivate y, so y1 is, this is in the form of u by v, so a sin x plus b cos x, so derivative of numerator is minus a sin x plus b cos x minus a cos x plus b sin x into a cos x minus b sin x upon a sin x plus b cos x the whole square. We shift this term to LHS, we get the required expression. So LHS is a sin x plus b cos x into minus a sin x plus b cos x minus a cos x plus b sin x into a cos x minus b sin x. So now this is in the form of a plus b, a minus b. So this is a square minus b square. So that is b square cos square x minus a square sin square x minus a square cos square x minus b square sin square x. That is b square cos square x minus a square sin square x minus a square cos square x plus b square sin square x. Taking a square and b square common, we get b square into cos square x plus sin square x minus a square sin square x plus cos square x. Now cos square x plus sin square x is 1. So we get b square minus a square, which is option C. If y is a tan x plus b upon a tan x minus b, then the value of b cos x minus a sin x the whole square into y1 is, these are the options. So we differentiate, first we convert tan x into sin and cos. So y is a sin x by cos x plus b upon a sin x upon cos x minus b. So this can be written as a sin x plus b cos x upon a sin x minus b cos x. So this is a y. So we differentiate y. So we get y1 is, this is in the form of u by v. So a sin x minus b cos x into differentiation of numerator, that is a cos x minus b sin x minus b into derivative of u minus u into derivative of v, that is a sin x plus b cos x into a cos x plus b sin x divided by a sin x minus b cos x the whole square. Shifting this term to LHS, we get a sin x minus b cos x whole square into y1 is equal to a sin x minus b cos x into a cos x minus b sin x minus a sin x plus b cos x into a cos x plus b sin x. So this is the same as b cos x minus a sin x the whole square. We expand the brackets, so we get a square sin x cos x minus ab sin square x minus ab cos x cos square x plus b square sin x cos x. Similarly, a square sin x cos x plus ab sin square x plus ab cos square x plus b square sin x cos x. So now taking a square and b square common, similarly ab, we take ab common, so we get there's a correction here, so this whole term is minus, so we are left with this gets cancelled, b square sin x cos x b minus b square sin x cos x. Similarly, a square sin x cos x and minus a square sin x cos x is cancelled. We are left with minus ab sin square x minus ab sin square x minus ab cos square x minus ab cos square x. Now we take ab common throughout the term, we get minus ab minus 2ab, since this and this term is the same. Similarly for this term, so minus 2ab sin square x plus cos square x, which is 1. So the final answer is minus 2ab, which is option C. So if y is x by 2, then differentiation of 2 sin x minus sin 2x upon 2 sin x plus sin 2x is, these are the options. Let this be y. So y is 2 sin x minus sin 2x upon 2 sin x plus sin 2x. Now sin 2x is 2 sin x cos x. So this is 2 sin x minus 2 sin x cos x upon 2 sin x minus 2 sin x cos x. We take 2 sin x common. We are left with 1 minus cos x upon 1 plus cos x. Now 1 minus cos x is 2 sin square x by 2 and 1 plus cos x is 2 cos square x by 2. So now this is sin upon cos, so this is 2 gets cancelled. We are left with tan square of x by 2. So y is tan square x by 2. So we differentiated, that is dy by dx is differentiation of tan square x by 2 is 2 into tan x by 2 into differentiation of x by 2, that is half, into differentiation of tan of x by 2, that is sec square x by 2. So 2 gets cancelled. Now x by 2 is u, x by 2 is u. So we substitute the value, we get tan of u into sec square u, which is option A. Differentiation of 1 plus cos 2x plus sin 2x upon 1 plus sin 2x minus cos 2x is, these are the options. So now d by dx of, now 1 plus cos 2x is, this can be written as 2 cos square x plus sin 2x is 2 sin x cos x. Similarly, this can be written as 1 minus cos 2x, so which is 2 sin square x plus again sin 2x is 2 sin x cos x. this is d by dx of, taking 2 cos x common in the numerator, we get cos x plus sin x divided by 2 sin x into sin x plus cos x. This term gets cancelled, 2 gets cancelled, we are left with d by dx of, now cos upon sin is cot, so this is d by dx of cot x, which is minus cosec square x, which is option C. If u is cos x plus sin x upon cos x minus sin x, which is equal to 1 by v, then the value of u dash minus v dash is, these are the options. We have to find u dash minus v dash. So first we find u minus v, and then we differentiate this with respect to x. So u dash minus v dash is du by dx minus dv by dx, which is equal to d by dx of u minus v. So v is the reciprocal of u. So this is d by dx of u is cos x plus sin x upon cos x minus sin x minus cos x minus sin x upon cos x plus sin x. These are reciprocals. We cross multiplied, so we get cos x plus sin x the whole square minus cos x minus sin x the whole square divided by, this is in the form of a plus b a minus b, so this is cos square x minus sin square x. So now a plus b the whole square minus a minus b the whole square gives 4ab. We use this property, so we get d by dx of 4 times cos x sin x, where a is cos x and b is sin x. So 4 times cos x sin x upon cos square x minus sin square x is cos 2x. So d by dx of, we split this term, so 2 into 2 sin x cos x upon cos 2x, which is d by dx of, this is sin 2x, so this is 2 times sin 2x by cos 2x, which gives d by dx of 2 tan 2x. So now we differentiate it with respect to x, so 2 into differentiation of tan 2x is differentiation of x, so 2 into differentiation of tan 2x, which is sec square 2x. So this gives us 4 sec square 2x, which is option D. U sec x plus tan x minus 1, v sec x minus tan x plus 1, then u dash v plus v dash u is what? So now u dash v plus v dash u is the formula for derivative of u into v. So first we find u into v, which is u is sec x plus tan x minus 1 into sec x minus tan x plus 1. This can be written as sec x plus tan x minus 1 sec x, taking minus common, tan x minus 1. So now this is in the form of a plus b a minus b, where a is sec x and b is tan x minus 1. So this is a square minus b square, which is sec square x minus tan x minus 1 the whole square. So that is sec square x minus a minus b the whole square, so tan square x plus 2 tan x minus 1, taking minus inside the bracket, now sec square x minus tan square x is 1, so 1 minus 2 tan x minus 1 is u into v, that is u into v is my this is plus, so u into v is plus 2 tan x. Now we differentiate this with respect to x, So this is u into derivative of v, u into derivative of v plus v into derivative of u, which is the LHS, required LHS. Now differentiation of 2 tan x is 2 into differentiation of tan x is sec square x, so which is 2 sec square x. So the answer is C, 2 sec square x. We have to find the differentiation of log of e raised to x into x minus 2 by x plus 2 raised to 3 by 4. These are the options. So firstly, by rule of logarithm, we split the term. So we get log of e raised to x. Log of a into b is log of a plus log of b. Log a plus log b. So this is log e raised to x plus log of x minus 2 upon x plus 2 raised to 3 by 4. Again using the law of logarithm, we get x times log e plus 3 by 4 into log of x minus 2 upon x plus 2. Now log e is 1. So d by dx of x plus, let this be y. So this is x plus 3 by 4. Now log of a by b is log of a minus log of b. So this is 3 by 4 log of x minus 2 minus log of x plus 2. So now we differentiate it. So dy by dx is 1 plus 3 by 4 into log of differentiation of log of log of x minus 2 is 1 by x minus 2, and for this term it is 1 by x plus 2. We cross multiply it, we get 1 plus 3 by 4 into x plus 2 minus x plus 2 upon x minus 2 into x plus 2. That is 1 plus 3 by 4. X gets cancelled. So this is 4 by, this is in the form of a plus b, a minus b. So this is x square minus 4. So 4 gets cancelled. So this is 1 plus 3 by x square minus 4, which is, again we cross multiply. So this is x square minus 4 plus 3 by x square minus 4. So minus 4 plus 3 is minus 1. So this is x square minus 1 by x square minus 4, which is option D. So let y be limit h tends to 0 x plus h raised to 4 minus x raised to 4 by h. So we have to find the value of differentiation of dy by dx, differentiation of y with respect to x. So dy by dx is d by dx of limit h tends to 0 x plus h raised to 4 minus x raised to 4 by h. Now this term can be written as x raised to derivative of x raised to 4, d by dx of x raised to 4 by first principle. So dy by dx is differentiation of x raised to 4 is 4x cube. So this is d by dx of 4x cube. Again we differentiate, we get 4 into 3 into x square, which is 12x square, which is option A. If y is 4 raised to log to the base 2 sin x plus 9 raised to log to the base 3 cos x, then the value of log 2 into log 3 into y1 is what? The options are 0, sin 2x, log 5 and 1. So first the law of by the formula laws of logarithm, we can say a raised to log to the base a, m is the same as m. So our purpose is to make this term and the base same. So in this case this should be 2 and this should be 2, this should be same and this should be same, so that we can simplify it further. So 4 can be written as 2 square. So 2 square into 2 raised to 2 times log to the base 2 sin x. Similarly for second term we can write 3 raised to 2 log to the base 3 cos x. Again by law of logarithm we get 2 raised to log to the base 2 sine square x plus 3 raised to log to the base 3 cos square x. Now applying this formula, we have y is sine square x plus cos square x. But sine square x plus cos square x is 1. So y is 1. So therefore y1 is y1. So this is a constant, so differentiation is 0. So therefore anything multiplied by 0 is 0. So the answer is A, 0. If x is b cos square theta and y is a sin square theta, then find the value of dy by dx. So first x is b cos square theta. Therefore x by a is x by b is cos square theta. Let this be equation 1. Similarly y is a sin square theta. So y by a is sin square theta. Let this be equation 2. Now sin square theta plus cos square theta is 1. So from 1 and 2 we can say x by b plus y by a is 1. So now we differentiate this term with respect to x. So we get differentiation of x is 1. So this is 1 by b plus differentiation of y is dy by dx into 1 by a is equal to 0. So that is dy by dx is minus 1 by b. That is dy by dx is minus a by b, which is option B. If x is a sec square theta, y is b tan square theta, then the value of dy by dx is, these are the options. So first x is a sec square theta, so therefore x by a is sec square theta. Let this be equation 1. Similarly y is b tan square theta, so therefore y by b is tan square theta. Let this be equation 2. Now we know that sec square theta minus tan square theta is 1. So from 1 and 2 we can say x by a minus y by b is 1. Now we differentiate this equation with respect to x. So this is 1 by a minus 1 by b into dy by dx is equal to 0. So that is 1 by b dy by dx is 1 by a. So therefore dy by dx is b by a, which is option D. If y is x raised to 2 by 3 minus x raised to minus 1 by 3 divided by x raised to 2 by 3 plus x inverse, then the value of x plus 1 the whole square into y1 is, the options are 2, 2 by 3, minus 1 by 3 and minus 3. So first we simplify this value of y. So this is x raised to 2 by 3. We can write this as 1 by x raised to 1 by 3 upon x raised to 2 by 3 plus 1 by x. Cross multiplied we get x raised to 2 by 3 into x raised to 1 by 3 minus 1 divided by x raised to 1 by 3 upon x raised to 2 by 3 into x plus 1 divided by x. So this is x raised to 2 by 3 into x raised to 1 by 3 is x. So x minus 1 upon, again this is x raised to 2 by 3 plus x is x raised to 5 by 3 plus 1. There's a correction in the question. So this is minus 1 by 3. So this is 1 by 3. Again this is 1 by 3. So this gets cancelled. This is 1 by 3. So we get x minus 1 upon x plus 1. Since x raised to 2 by 3 into x raised to 1 by 3 is x. So this is y. So now we use u by v rule. So this is dy by dx, which is equal to differentiation of u by v is v into derivative of u, that is 1, minus u into derivative of v, that is 1, divided by v square, that is x plus 1 the whole square. So this is x plus 1 minus x minus 1 upon this is x minus 1 since this is u. So this turns out to be x plus 1 minus x plus 1. So this is x gets cancelled. This is x plus 1 the whole square. So this is 2 by x plus 1 the whole square. This is dy by dx. That is y1. So x plus 1 the whole square into y1 is 2, which is option A. If x square plus y square is t plus t inverse and x raised to 4 plus y raised to 4 is t square plus t raised to minus 2, then the value of y into y1 is, the options are x raised to minus 2, minus x raised to minus 3, x inverse and minus x inverse. So first x raised to 4 plus y raised to 4 is t square plus 1 by t square. Let this be equation 1. X square plus and x square plus y square is t plus 1 by t. T plus 1 by t. Let this be equation 2. Now we square this equation. So we get x square plus y square the whole square is t plus 1 by t the whole square. That is equal to x square plus x raised to 4 plus y raised to 4 plus 2x square y square is equal to t square plus 1 by t square plus 2 into t into 1 by t. T gets cancelled. So we have now x raised to 4 plus y raised to 4 is t square plus 1 by t square from equation 1. So this is t square plus 1 by t square plus 2x square y square is equal to t square plus 1 by t square plus 2. Now this term gets cancelled. We are left with 2x square y square is 2. That is x square y square is 1. That is y square is minus 1 upon x square. Now we differentiate this with respect to x. So this is 2 into y into dy by dx is equal to, this is minus x raised to minus 2. So differentiation of x raised to n is n into x raised to n minus 1. That is minus of minus 2 into x raised to minus 3. So 2 gets cancelled. We have y into y1 is equal to x raised to minus, this is plus, this is plus, this is plus, again this is plus. So we are left with y into y1, which is first derivative of x, is minus x raised to minus 3, which is option B. If f of x is root of ax plus a square by root of ax, then the value of f dash of a is, the options are 0, minus 1, 1 and a. So first f of x is root of ax plus a square upon root of ax. First we simplify this term, so we get root of a into root of x plus a square by root a can be written as a root a, so into 1 by root x. Now we differentiate this. So f dash of x is, differentiation of root x is 1 by 2 root x. So a by 2 root x plus a root a. Differentiation of 1 by root x is 1 by 2 x root x. So this is 2 times x root x. So f dash of x is, now we put x equals a. So that is f dash of a is root of a upon 2 root a plus a root a upon 2 into a into root a. So this gets cancelled. There is a minus sign here. The differentiation of 1 by root of x is minus 1 by 2 x root x. So this is minus sign. So this term gets cancelled. We are left with half minus half, which is equal to 0. So the answer is A, 0. If x is t times log t and y is t raised to t, then the value of dy by dx is, the options are 1 by y, e raised to x, y by xt and log x. So firstly x is t log t. Now by law of logarithm we can write this as log of t raised to t, but t raised to t is y. Therefore x is log y to the base e. So we can write this as alternatively y is e raised to x. So now we differentiate with respect to x. So we get dy by dx is d by dx of e raised to x, which is the same as e raised to x. So the answer is B, e raised to x. If d by dx of 1 plus x raised to 4 plus x raised to 8 by 1 plus x square plus x raised to 4 is ax cube plus bx, then the value of a and b are, options are 4 comma 2, 4 comma minus 2, minus 2 comma 4 and minus 2 comma minus 4. So first we simplify the numerator. So we have 1 plus x raised to 4 plus x raised to 8. We can write this as 1 plus 2x raised to 4 plus x raised to 8 minus x raised to 4. So this is the same as 1 plus 2x raised to 4 the whole square minus x square the whole square. So this is in the form of a plus b, a minus b, that is a square minus b square. So this can be written as, this is 1 plus x raised to 4, so this is 1 plus x raised to 4 plus x square into 1 plus x raised to 4 minus x square. So this is the numerator. So we have to find d by dx of 1 plus x raised to 4 plus x raised to 8 divided by 1 plus x square plus x raised to 4, which is equal to 1 plus x raised to 4 plus x square into 1 plus x raised to 4 minus x square divided by 1 plus x square plus x raised to 4. This term gets cancelled. We have to d by dx of 1 plus x raised to 4 minus x square, which is 0 plus 4x cube minus 2x. So comparing this with ax cube plus bx, we get a is 4 and b is minus 2. So the option is a comma b is 4 comma minus 2, which is option B. If y is 1 plus x raised to 1 by 4 into 1 plus x raised to half plus 1 minus x raised to minus 1 by, x raised to 1 by 4, then the value of dy by dx is 1 minus 1 x or root x. First we simplify this expression. We have 1 plus x raised to 1 by 4. We can rewrite this as 1 minus, we rearrange this term. So x raised to 1 by 4, 1 plus x raised to half. So this is in the form of a plus b, a minus b. So this is a square minus b square, that is 1 square minus x raised to 1 by 4 square into 1 plus x raised to half. So this is 1 minus x raised to 1 by 2 into 1 plus x raised to 1 by 2. Again we have a plus b, a minus b form. So this is a square minus b square, that is 1 square minus x raised to 1 by 2 square, which is equal to 1 minus x. So y is 1 minus x. So therefore dy by dx is minus 1, which is option B. If f of x is 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial plus so on and so forth till infinity, then the value of f dash of x is what? The options are x factorial, e raised to x, e raised to minus x and 0. So now f of x, which is equal to 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial and so on and so forth till infinity. This is defined as e raised to x. The definition of e raised to x is 1 plus x upon 1 factorial plus x square upon 2 factorial up to infinity. So f of x is e raised to x. So therefore f dash of x is again e raised to x, which is option B. Differentiation with respect to x of log of x upon e raised to cot x is, the options are 1 minus cosec square x, minus 1 minus cosec square x inverse minus cosec square x inverse plus cosec square x. So first, by law of logarithm, we get log of x minus log of e raised to cot x, that is d by dx log x minus, So this came from log of a by b is log of a minus log of b, and for this log of a raised to b is b log a. So this is cot x into log e. Now the base is e, so therefore log e is 1. So d by dx of log x minus cot x is what we have to find. So we differentiate it with respect to x. So this is 1 by x minus differentiation of cot square is minus cosec square x. So this is minus cosec square x, which is equal to x inverse plus cosec square x, which is option D. If p into v is 81, then dp by dv at v is equal to 9 is, the options are A, b minus 1, c 2 and d root 9. So first it is given that p into v is 81. So we have to find the value of dp by dv at v equals 9. So for v is equal to 9, p is 81 by v, which is 81 by 9, which is 9. So p is 9 and v is also 9. So now p into v is 81. So now we differentiate it with respect to v. So this is in the form of u into v. So we can write this as d by dv p into v equals d by dv 81. So this is p into derivative of v, that is 1, plus v into derivative of p, that is dp by dv. So this is a constant, so this is 0. So now p is 9, so this is 9 plus v is also 9 into dp by dv equals 0. So we take 9 common, so we have 1 plus dp by dv equals 0. That is 1 plus dp by dv is equal to 0. So we take this to the RHS, we have dp by dv is equal to minus 1 for v is equal to 9. So the answer is b minus 1.